Hi. Last time we talked about trig equations, and the focus there was on just linear equations. There was some condition that involved sine or cosine, for instance, that you could manipulate to come up with a value of the sine or cosine tangent functions. And then facts about how the inverse trig functions work, how to recover an angle from a value of the trig function, were used to come up with solutions to the equation. Today it's going to be a little more algebraically involved. Today we're going to talk about how to solve more general equations. Now typically there's going to be two things that can make it more complicated. One is that it could be more complicated algebraically. Maybe what's involved is not just a linear equation, but a quadratic equation. So you have to remember how you solved quadratic equations by factoring and use that to first factor the trig equation and then apply facts about the linear kinds of trig equations from last lecture to solve. The second way it can be involved is if it has more than one trig function in it. If it's going to be based on algebra, what you need to have happen is that a single trig function of a single angle plays the role of just the variable in an algebraic equation for the first part of the solution. If you don't have that, if you've got a trig equation that involves sine and cosine or secant and tangents, then you need a way to replace some combination of those trig functions so that you can apply that algebraic technique. So some trig identities might come in handy that would let you do some substitutions so that you just have a trig function of a single angle.